Right, now write down the heading as questions related motions in reverse. Motions in reverse. Questions related motions in reverse. Right. Now suppose here we have a river. The banks, these are parallel. This is a bank, this is a bank, these banks are parallel. Water flows this way with velocity u. We assume here the velocity of water being equal everywhere across the river. Therefore, W stands for water or the river. I take river. Water also correct. And E stands for earth. Now suppose a man swims on this, in this river, right? Making his body with this bank angle theta. Making an angle theta with upstream, right? Even now, the direction to which the water flows is called as downstream, right? Downstream. Downstream. The other direction we define as the upstream. Upstream, right? Now here this man makes his body making an angle theta with the upstream, right? Now suppose the velocity of this man relative to water as v. Then he moves along this direction. M stands for man. Right. Now velocity of water relative to earth. Velocity of water relative to earth. Downstream direction u. Velocity of man relative to water. This way v. Making an angle theta. People, we have to very carefully understand this. Velocity of man relative to water. Velocity of man relative to water means, right? Now, suppose people this way. We have a lake. You know, in a lake, you can't see a flow of water. The water is stagnant, rest. Or consider a pool, swimming pool. In a pool also, people, not like a river, water is not flowing in a swimming pool. Water is stagnant, rest. In such water surface, when a man swims, in such water surface, when a man swims, he can swim with particular velocity, no? That velocity only, people, we define as velocity of man relative to water. Correct, no? Relative to water means what should be at rest, no? That's how we said, no? Velocity of man relative to water means the observer is water. What should be at rest? When we consider a lake or swimming pool, water is not flowing like a river, it is stagnant, rest. When we consider such surface of water, and if man can swim in such water surface with a particular velocity, that velocity only, people, velocity of the man relative to water. Therefore, here, this man can swim, right, on a lake or a swimming pool with the velocity v. That's what it says. Right. Well, now what happens is next this. Now, when this man, without swimming with velocity v, suppose he floats on the water surface in the river. Then what happens? This man will be getting the velocity of water u automatically. Right? When this man floats on the water surface, because of this water is flowing, definitely that velocity of water comes to this man. So therefore, if the man is floating at rest without swimming, he gets this velocity of water automatically. Then to his body, the velocity, suppose this is the man, this velocity u automatically comes because he is floating on the water surface. Now, if the man swims this way, the velocity of the man while he is swimming coming along his body this way. And now people, man has two velocities. One velocity is this u that is coming automatically to this man by the water because he is floating on the water, water is moving, then automatically that velocity comes to the man. And meantime, he generates himself another velocity, spending his energy. It is v that acts along his body. Then finally, this man will have a resultant velocity along this direction, suppose this angle is theta. Then this resultant velocity only people we define as the velocity of the man relative to earth. Then finally, this man will be moving to this direction, keeping his body this way. Right? So therefore, this man will be moving along this direction. Along this direction, keeping his body like this. That's what really happens. His body is like this and moves along this way. This velocity of resultant velocity of this u and v, now you can find by using the component forms how we have to convert these two velocities. One is horizontal and one is vertical, as we did earlier. How to find that, people? This direction u we have, and by this v we get the component this direction v cos theta. And another vertical one, this v sin theta. V sin theta. Here 90. Then u minus v cos theta, when you so write word, people, this v cos theta we can write here as this way, minus v cos theta. The result of these two only, people, velocity of the man relative to earth. Since these two velocities are perpendicular velocities, we can find the resultant velocity. Understand? Thereby we can find the velocity of the man relative to earth. Thereafter, using these two velocities, people, we can calculate many things there. Right? So therefore, in this case, we have to really understand when this man moves, swims, usually we are given velocity of the man relative to river. Velocity of the man relative to river. It means, people, this. When this man swims on a water surface that is stagnate, rest, what is the velocity this man can create, produces? Right? He can produce. That is the velocity of the man relative to river. Okay. Then in this way, when man swims on the water surface in the river, he has that velocity. Meantime, the velocity of the river he gets automatically. Then finally, man has two velocities. This way, for them there is a resultant velocity. That velocity we define as the velocity of the man relative to earth. Now finally the man moves across the river to that direction with that velocity, keeping his body this way. Understand? So then using this motion, we can do some theories and thereby we can come to questions. Understood? Right? Yeah, any question here, people? Yes? Any question? No. Right. So now we'll then write brief note like this. Write down. Consider a river. Consider a river with straight parallel banks. With straight parallel banks of wide WIDE of wide simple D of wide simple D flowing with uniform velocity simple U flowing with uniform velocity simple U. Write down, let a man capable of swimming with velocity v relative to water with velocity v relative to water begins to swim begins to swim across the river from a point on a bank from a point on a bank making an angle theta with upstream right. First draw this diagram. Draw this diagram, people. Right. Okay, now you can write this way. Right. when the man begins to swim, he will automatically get the velocity of water downstream, velocity of water simple u, velocity of water simple u downstream, and his velocity v along his body. Now, he has two velocities. And the resultant velocity of these two velocities is his velocity relative to Earth. Yeah, now you can take that velocity people like this. He will get velocity of man relative to Earth. He has this wave velocity u, this wave velocity v. This angle is theta. Right? These two velocities I can resolve. This way v sine theta, this way we have u, but by this v we get v cos theta leftward, that I write as rightward minus v cos theta. Here 90. Right. Now velocity of man, now we have in component form. This way v sine theta, this way u minus v cos theta. Here 90. Right. Now people, if I explain the situation now this way, now this man has here one velocity this way v sine theta, the other velocity is this way u minus v cos theta. Now because of these two velocities, man actually moves along a path like this, no? Man moves along a path like this. But remember, when he moves along this path, his body is always pointing, making an angle theta with the upstream, like this. His body is always pointing like this, keeping pointed an angle theta with the upstream direction. Then finally, he will be coming to the other bank at a point somewhere here. Initially, he was here. Once he comes to this point, people, you can very clearly understand he has moved a particular distance down along the stream. And also, he has moved perpendicular to the bank. This is a length. So, if I construct that, you can see initially he is here, finally he is here. Then he has moved downstream direction, a particular displacement. And not only that, he has moved from here to here also. He has two displacements, downstream and perpendicular to the bank. People, this downstream displacement, this man gets because of this velocity. The perpendicular direction, the displacement is equal to the width of the river. Do you know this displacement d is taken by this man because of this v sine theta velocity, right? Now you can calculate the time he has taken to get across the river. People, now when he is coming to this point, right, he has moved perpendicular to the banks a distance d with velocity v sine theta. Then the time taken by the man to get across the river can easily be found dividing this d by v sine theta. Understand? During that time interval, the displacement traveled downstream, you can find multiplying this velocity by that time. That way, very easily we can calculate these things, right? First, draw this diagram and we'll do that calculations. First one, we can write time to get across the river. Right. First one, write down time to get across the river. Right. Time to get across the river can be found this way. When the man starting from here comes to this point on the other bank, during that motion, he has moved perpendicular to the banks d, parallel to the banks this. Then this d displacement he has moved with velocity is v sine theta. Then time is what? Displacement divided by the velocity is the time. Time is displacement divided by the velocity, right? Therefore, the time t equals d divided by v sine theta. This is the time he takes to get across the river. During this time interval, the displacement the man has moved downstream can be found using S equals ut. We'll write like this. During this time, the displacement moved downstream. Using S equals ut, you can write. Using S equals ut, you can write what people? U is now u minus v cos theta. T is the time here we found. D divided by V sine theta. This is displacement, it moves. He moves, right? Right. Next thing is this. Right now, people suppose this man need to get across the river as soon as possible. This man need to get across the river as soon as possible. That means this T must be minimized. To minimize this T, this denominator should be maximized. But this V cannot be increased. Why? It is the velocity of the man relative to water. This is his maximum velocity. He can swim on a stagnant water surface. Then to maximize this denominator, we have to maximize this sine theta. But you know, maximum value of sine theta is 1. Then when you put 1 here, the minimum time coming as d upon v. That occasion, what is sine theta? Sine theta is 1. People, you know, when sine theta is 1, theta is pi by 2. What do you mean by this? If this man wants to get across the river as soon as possible, the time he takes is what? Sine theta 1 means d upon v. To get across the river, that theta must be pi by 2. That means this man should turn his body perpendicular to the bank. Theta 90 means that, no? Perpendicular to the bank. So therefore, in order to get across the river in the shortest time, the man should point his body perpendicular to the river and swim. Then his body is like this. Understand? That occasion, he will be moving along a path like this. That occasion, we can find the displacement he has moved downstream during this time interval. Okay, right. Now you can write number 2. Minimum time to get across the river. Minimum time to get across the river. Minimum time to get across the river. You can write for this T to be minimum, sine theta should be 1, right? T is d upon v sine theta now. Now you can write for T to be minimum, sine theta should be maximum. But sine theta max is 1. Therefore, theta is pi by 2. Hence, T minimum is equal to d divided by v, because sine theta is 1 now. Right. Minimum time is what? D upon v. Take this. Minimum time is d upon v. Now you can write in this way, in order to minimize the time to get across the river, since that theta is pi by 2, mean the man should turn his body perpendicular to the bank and should swim. Right now, and then you can write, in order to minimize the time to get across the river, man should swim keeping his body perpendicular to the banks. Perpendicular to the banks. Perpendicular to banks. Write down. During this time, the distance the man moved downstream at people. Now, how to analyze that? Here, this is the way this man now swim. This is 90. Now his velocity is what? V, right? His velocity is V. This direction velocity is what? U minus V cos theta. But in this case, what is theta? Because 90, no? When you put here theta, 90, cos 90 is 0. Then V into 0 is 0. Then we get U here. Then downstream velocity is U, people. Why? Man keeps his body perpendicular to the bank. That means this theta 90. Theta 90. Theta 90 means here theta 90. Cos 90 is 0. Then we have U. Then this man moves this way. Along a path this he moves. Then ask him what? This length. What is that? If I take that as S equals U times the time he takes is d upon V. U d by V. This is the distance. People, now what is this distance? The distance of the path of the man, if we take this as L, this is D now, then you can find this actual distance this man moves across the river is L. You can find that by using the Pythagoras theorem, right? Also, you can write also the distance man will move crossing the river is what is people? L is L. L can be found how? L is equal to what? Du squared plus S squared. S is this, no? Du by V perfect square root. Then you can take this D out, D squared out, that will be D 1 plus U squared upon V squared. Take this V squared as the common denominator and take that V out. D upon V square root of U squared plus V squared. This is the actual distance he moves crossing the river. Right now, people. Right. Another one case we can consider. Right now, in this case, people, this man is moving along this line, but keeping his body perpendicular to the banks like this. Okay, this is how he now keeps his body. Right? Yeah. Right now, another one case we can consider here. Right now, suppose this man, right, starts the swimming here now, people. Suppose now he need to go to the other bank, which is directly opposite to this point on the other bank. This man needs to land on the other bank at a point which is directly opposite to this point. That means he should move along a path perpendicular to the bank. Finally, his path should be perpendicular to the bank. Understand? On that occasion, you know, this man need to move relative to earth along a direction perpendicular to the bank. Then he should not have any displacement down along the bank or up along the bank. That means this u minus v cos theta velocity should be 0. Then only he will not have any displacement downstream or upstream. Then he will be moving with this velocity v sin theta perpendicular to the bank. Understand? Now that is our next case. Write down that as number 3. Right? People, for convenience, I'll take this point as A. Right now, write down number 3. If the man wants to land on the other bank, which is directly opposite, to the point A. This is A. Man should come to the other bank, suppose B. That AB line is perpendicular now. Then this is the path the man should move relative to earth. Relative to earth, man should move along this direction. You know, when he moves along this path, since he has no downstream or upstream displacement, correct? No, moving perpendicular to the bank means he has no downstream or upstream any displacement. For this u minus v cos theta velocity should be 0. Then only he has no downstream or upstream displacement. right? And then only he can move along this path. Okay. Now draw this diagram and we'll write. Now write down. In this case, the man should not have, in this case, this man should not have a displacement parallel to the bank, u minus v cos theta should be equal to 0. U minus v cos theta should be equal to 0. Now you can subject cos theta by this. This implies cos theta brings this side and divide by v, u upon v. That means people what? Theta cos the inverse u upon v. People, what is theta? Theta is this angle. Then this man should point his body along a direction like this, so that this theta is cos inverse u upon v. Then the man should point his body this way. Man should point his body along this direction. What is this angle? This angle is cos inverse u upon v. Cos inverse u upon v. Right? But you know, people, cos theta less than 1, no? Also cos theta less than 1. We know for any angle, cos is less than 1, no? Maximum value of cos is 1. Then for this, cos theta is u by v, no? Less than 1. Then using this way, u less than v, that means what? V greater than u. What is this, people? For this to occur, definitely the velocity of man relative to water should be greater than the velocity of water, Then only this man can swim in a path perpendicular to the bank, so as to land on the other bank, which is directly opposite to this point. He begins the motion. Otherwise, if this condition is not there, man can't swim to the directly opposite point on the other bank. Then, people, in this case, the time can be calculated. Now, what is the velocity there with which he moves now? V sin theta, no? He moves with velocity v sin theta now, because his velocity is this, no? And then this direction v sin theta. But we have theta, cos theta is u upon v. Now you can write, in this case, the time he takes. In this case, the time he takes. He takes to get across the river. What's time, people? T divided by the displacement he moves, d, the width of the river. What is the velocity v sine theta. D upon v. How to write sine theta? Sine theta means square root of 1 minus cos square theta, no? Right. Then what do you get? The time d upon v square root of 1 minus cos theta is people u upon v. Cos square theta means u squared upon v squared. Then we can take this v squared here. V squared minus u squared divided by v squared. Take that v squared out. That and this we can cancel down, right? Then you can write d equals d upon v times the square root v squared minus u squared divided by v squared. Take this out, that will be v. That v and this v we can cancel down. Therefore, t is equal to d upon square root of v squared minus u squared. Right. So therefore, people, this case means the man get across the river swimming only the wide of the river. Only the wide of the river. He goes to other bank, just moving the wide of the river. For this condition must satisfy. What is that? His velocity relative to water should be greater than the velocity of water. Otherwise, he can't move to the other bank, which is directly opposite to the point of starting. Okay. That means this question might ask how, if this man gets across the river by swimming only the wide of the river, then find the condition and the time. That means he has moved only the wide of the river just before getting across the river. That means the d, only the distance he has moved, d. Then for this, the man should move perpendicular banks relative to earth. For this, he has to turn his body this way, making cosinus u upon v with the upstream. Then he will be moving along this path, this way. Then his body points always people this way. Body points this way. Right. Okay, no? Right. Now, another one case we can consider. Now here, v greater than u, this condition should satisfy in order to get across the river by moving only the wide of the river. But suppose this does not occur, then this man has no chance to land on the other bank, which is directly opposite to this point. Definitely, he should go a little distance downstream and should go to the other bank to a point, but that is not directly opposite to the point he starts on this bank. In that case, this man can minimize the distance he goes downstream by selecting this angle correctly. We'll come to that part as number 4, right? Number 4. Okay. I'll write down like this. If v less than u, Write down. If V less than U, the man has no chance. The man has no chance. The man has no chance to reach. The man has no chance to reach to a point on the other bank, to the point on the other bank, to the point on the other bank, which is directly opposite, which is directly opposite which is directly opposite to the point capital A. In this case, he moves a certain distance downstream, a certain distance downstream, while he gets across the river. While he gets across the river. The man can, write down, the man can minimize this distance. This man can minimize this distance by choosing the suitable angle for theta. The suitable angle for theta. Right. Write down. This angle can be found as follows. Right. Okay. I'll do it now like this. Now we have the present data like this. Velocity of water relative to earth, this direction u. Velocity of man relative to water v. But we can't say this direction theta because theta is unknown. That theta only we are going to find. Okay. Right. What is the question now? Theta. We need to find theta to minimize the distance this man moves downstream. We need theta for this direction displacement minimize. Write down. We need theta for downstream displacement to minimize. Right now, write down this way. We need theta for downstream displacement to minimize. Now, in this case, people, we use the principle of relative velocity by subjecting the velocity of the man relative to Earth. Then remember here, v less than u. And now we can write using the principle of relative velocity. We can subject velocity of this man relative to river is equal to v m w plus v w e. Now, what is the method? Whenever we use the principle of relative velocity, for these velocities we have to put vectors. No, this is pq vector and this is qr vector. Therefore, this is pr vector. Right. Now, PQ vector gives the velocity of man relative to water. It is v, but its direction is unknown. Understand? And then we write v. We can't draw a line segment for this PQ because the direction is unknown. That direction only we need to find. Then we write it like this: size of the velocity is v, but that is represented by PQ. This is how we write that. The size of this vector is v, represented by PQ. We can't draw a line segment PQ because we don't know exact direction. QR, WE, this way. Now, WE means here, you know, downstream. It is represented by QR. This is U. Now, people, it is not easy to draw a triangle this time. The reason is this velocity, we know its size, but direction is unknown. In this case, people, what we do is this. Remember, in this case means one velocity we know with size and direction both. Another velocity we know only its size, the direction is unknown. In this case, people, what we do, we draw a circle. How? You know, to the right hand side, there is a common point. Here PQ, here QR. What is the common point? This Q, no? Here we have Q, here also we have Q. Right? We take that Q as the center. We draw a circle. Its center is the common point on the right hand side. Q, no? Q is the common point. We take Q, the common point, as a center of the circle, and its radius we take as this v. What? The velocity whose direction is unknown. Understood? Right? Then I'm going to draw that circle. Right here. Center is Q. Right? Center is Q. Radius is V. But we know, people, V less than U. This radius is V. V less than U means U is this velocity, no? R is here. This is now U. This radius is V. Right. Now, to draw the triangle, people, we need to find the point P. Right. Now, point P should be on this circle. Why? This PQ length is V, no? The radius of the circle is V. Then the distance from Q to any point on the circle is V. So therefore, this point P should be on the circle. Why? PQ distance is V. Because PQ vector size means PQ distance, no? The size of the PQ vector is V. That is why we say the point P should be on the circle. Now, we need to find point P such that this velocity of this man relative to Earth is given by PR. Right? PR. Now, people think like this. In this case, we said, now man is starting from A, no? Right. Now, suppose he points his body like this. Now you can see, finally, the man moves this direction. Right. Man moves this direction. Then his displacement down along the river is this. What is this? His direction of motion relative to Earth. You can very clearly understand, if this downstream displacement is S, you can decrease this S if we select this velocity, this direction. See here, if the velocity of this man is not this direction, is this direction, now what is the displacement he moves downstream? This. If we further bring this velocity, people, this way. This velocity means what? Velocity of the man relative to Earth, this way. What is the displacement downstream? This direction, people, is given by PR. Then we have to select a point P on this circle so that when we join that P and R, that should make this way great angle, maximum possible angle with this downstream direction. Downstream direction means this. Then when we have to select a point P on the circle so that when we join that P and this R, that PR line should make great angle. This angle should be greater. If we select such point on the circle, people, and when we draw this PR, you can see when we select a point P here, this is that angle. Now, when I bring that point P here, now that angle greater than earlier. Like that, when we bring this point here, the angle even greater. Then you can see this angle will be greatest when we select a point P on the circle so that PR will be tangent to the circle. Understand? So then only this velocity turn in this way, and thereby this displacement downstream of the bank will reduce. So therefore, now when we select the point P on the circle to complete the velocity triangle, we have to select point P on the circle so that PR becomes a tangent. Understand? Okay. All right. So then we select this way. Right. We select a point P so that PR becomes a tangent. All right. So then this is the PQ. This is VR, right? Right, people. Now we select point P. Point P should be chosen on the circle so that PR becomes a tangent. Then PQ vector always given what people? PQ vector gives us velocity of the man relative to water. Now, this is the direction to which this man should turn his body while swimming. That means if I draw here horizontal line, this angle we have to find. This angle is equal to here. Suppose this is alpha. Then you can find that alpha. Then this is the angle there we found as alpha. Man should turn his body this way. To minimize the displacement, he goes downstream direction. Understood? Right? Then you can come here and draw a circle. Now you know the reason why should we select the point P so that PR becomes a tangent to the circle, right? Yeah. Okay, people, now write this. Right. First draw this. Right, write down. In this case, we should select the point P on the circle we should select the point P on the circle so that PR becomes a tangent to the circle. PR becomes a tangent to the circle. PR becomes a tangent to the circle. Right. Then people, you can find this alpha. What is cos alpha? Cos alpha adjacent divided by hypotenuse, V upon U. Then alpha is cos inverse V by U. That means what, people? The man must make this angle as alpha given by cos inverse V by U. Right. Now if I draw that diagram again here, now man should turn his body in a direction like this. Alpha. Cos alpha is given by V by U. Now his velocity is this direction, people. V. Then what is the direction, the velocity along this direction? It is U minus V cos alpha. Right. Now what is this PR? PR is the velocity of the man relative to Earth. With these two velocities, when man moves with the resultant velocity of these two. That velocity only given by this PR. PR can easily be found, people, by using the Pythagoras theorem, right? PR can be found by using the Pythagoras theorem. What is that? U squared minus V squared root, no? Right? PR is that. Now, people, can you tell me, in this case, how to find these things? The time this man takes to get across the river. Number one question is this. Number two, the distance the man moves downstream. And number three, the distance really the man moves before getting across the river, this distance. Okay. And if we draw a perpendicular like this, people, this is the distance this man moves down along the bank. That's the minimum distance. This distance, the width of the river. This is the distance really this man now moves. That can be found by using the Pythagoras theorem. Right. Then you can write like this. Write down. In this case, the minimum, in this case, the time. In this case, the time man takes to cross the river. Man takes to cross the river. What is the time, people? What velocity? Perpendicular to the bank velocity only, helping him to cross the river by moving y simple d of the river. Then what is the time? T is d upon v sine alpha. V sine alpha. How to write sine alpha? Square root of 1 minus cos squared alpha. Square root of 1 minus cos squared alpha is the sine alpha. Cos alpha is v by u. T equals d upon v. 1 minus cos alpha is v squared upon u squared. Simplify this. This is the time. Therefore, you can write time. This u squared should come here. Then take that out. Then u upon v. ud upon v. ud upon v root u squared minus v squared. This is the time. Right? This is the time. Right. During this time, we found with this velocity, the swimmer moves downstream. Then this distance we can write using s equals ut. Using s equals ut, this direction, this length you can write. If I take this length as simple a, that simple a you can write. U is downstream velocity, u minus v cos alpha. Time is t, just now here we found ud divided by v times this, u squared minus v squared root cos alpha. We can put here. Put that cos alpha here. A equals u minus v cos alpha is v by u into ud divided by v times this. Simplify this now. A is equal to here u squared minus v squared into ud upon v times the square root u squared minus v squared. Simplify this. U and u you can cancel down. This root we can cancel down with this. Then A is equal to square root of u squared minus v squared into d divided by v. Right. Now, people, what is the actual distance? This. That can easily be found, people, multiplying along this direction with which velocity the man moves. Velocity relative to Earth. Velocity relative to Earth is given by PR with this magnitude. Then this length can be found, that velocity multiplied by time. Or else, here this AB found, this width of the river we know, then this length you can find by using the Pythagoras theorem. Both are the same. Then actual distance the man moved. The distance, therefore the distance man moves before crossing the river is, let us take people this as L. L equals velocity what? Square root of u squared minus v squared. Time is this ud divided by v times square root of u squared minus v squared. This and this you can cancel down. L is ud by v. People, now by using this theory part, I think all the questions we can do in the tutorial first page, all the questions relating to motion in reverse. Okay, no? Now in your tutorial, try to do people the first 6 questions. The first 6 questions. You can do them. We can start a question now. But first complete this. Right now. Right, people, in the tutorial, take the question number 1. Take the question number 1. We'll do that one. Take the question number 1 in the tutorial. Read question number 1. And question number 1 says, in a river flowing with steady velocity, a man can swim with maximum velocity u downstream. In a river flowing with steady velocity. Right. Flowing with steady velocity, a man can swim with maximum velocity. I'll take the velocity of the river as w. Velocity of the river as w. Velocity of the man relative to river as, I'm going to take that as w dash. Velocity of river relative to earth is w this direction. Velocity of man relative to river is w dash. Now saying here, In a river flowing with steady velocity, a man can swim with maximum velocity u downstream. People, when the river is flowing this way with velocity down, man has the velocity w dash. In order to get the maximum velocity downstream, how should this man swim? He should swim people, pointing his boat this way to get the maximum velocity. Then this w automatically comes to him. His velocity w dash comes this direction. Then total velocity is going to be w plus w dash. That is the maximum velocity this man can achieve downstream direction. Then w plus w dash is the maximum velocity, but that is given as u. Number 1. Then next one asking the maximum velocity of the man upstream. Maximum velocity upstream. To get the upstream maximum velocity, he should point his body this way, upstream. Then he will get velocity w dash, and this water brings him down w. Then upstream direction, the maximum velocity is w dash minus w. It is given as v. It is number 2. Now what is asking? Show that the maximum velocity of the man in still water. This w dash is asking. How take? At 1 and 2. W and W you can cancel down. 2w dash u plus v. W dash is u plus v by 2. Next one. If the width of the river is d, this is d given now. Show that the minimum time to cross the river is distance. People, you know, in order to minimize the time to get across the river, how should this man swim? We said he has to turn his body, keep in perpendicular to the banks, this way. He has to turn his body perpendicular to the bank, and now he has to swim. Then what is the velocity helping him to get across the river perpendicular to the banks? His velocity is w dash. This w dash only, people, helping him. And then this is d now. Then what is the time? Time is d upon w dash. Then put this w dash here. U plus v divided by 2. Bring this 2 here. 2d divided by u plus v. See here, since we know the theories, we can very easily take the answer. And during this time, the distance moved to downstream is during this time, the distance moved to downstream. Right? What is the distance moved to downstream, people? Yeah, this man is brought to downwards with velocity w, the velocity of the river. W can be found by solving these 2 equations. Then the displacement, he is moved to downstream, going to be S equals W times T. What is W? W can be found subtracting these 2 equations, 1 minus 2. 1 minus 2 gives us w dash you can cancel down. 2w is equal to u minus v. Then w is u minus v by 2. Then put that pair here with this t here. Then we get the downward displacement. Understood? Therefore, S equals, w is u minus v by 2. T is this 2d divided by u plus v. 2 and 2 you can cancel down. S is equal to u minus v divided by u plus v times d. That answer we can take like this. So if you know these theories, people this way, very easily you can take the answers. Right? So that the minimum time to cross the river, you should know there, in order to get the minimum time, the man should turn his body perpendicular to the what? Bank. Then his velocity relative to water, that means the velocity he can produce himself is pointing now perpendicular to the bank. That is the velocity helping him to get across the river by moving the displacement d. Now that velocity of water acting on his body downstream, during that time interval, he will be moved down with that velocity. Then that can be calculated by this way, s equals ut. Right? Okay. Right.